Hello everyone, my name is Rahul. I'm a product engineer in the Esri location referencing team. With me here is Eric, who is a developer in the same team. We build and maintain both the ArcGIS roads and highways and pipeline referencing solutions. We'll term both roads and highways and pipeline referencing as location referencing here. In this presentation, we'll first show how to prepare location referencing data for publishing web services, then how to edit using web services, and finally, how to create and use your own app to edit the location referencing datasets. To give an idea of where both of our solutions are at, we are excited to bring roads and highways into ArcGIS Pro. For APR, we have a fully released solution, with the latest being ArcGIS Pro 2.8, which pairs with Enterprise 10.9. In this presentation, after deploying the location referencing database, we will show you how to expand the scope of your GIS by leveraging the power of location referencing REST API. Location referencing has two paradigms. One with traditional versioning, connecting directly to the geodatabase, and then our new paradigm, publishing and consuming feature services from ArcGIS Pro as well as any other web apps that you choose to build to extend the location referencing API. Today, we are talking about our new paradigm, which integrates location referencing services and capabilities into any application via a REST API. What it can do for you: you can automate your complex workflows, it saves time and effort, and it needs very little training once the workflow is established. Finally, it is platform independent and innovative. So some of you might be thinking, I have access to pipeline referencing in Pro, or I am interested in being an early adopter for roads and highways in Pro. How can I start using the new API? That's going to be the focus of the presentation today. We are going to give a quick view of the configuration and publication routine to get started. Then we'll make some edits in both ArcGIS Pro and directly via the REST endpoint, utilizing the same feature service. In case anyone does not have access to the recording or to the demo later on, we are including steps and screenshots in these slides towards the end of the slides. Well, before starting the demo, a brief introduction of the branch version data that is used for REST-based editing. Branch versioning is a new platform for multi-user editing that leverages a service-based architecture instead of depending on a database connection. Here is a step-by-step workflow for publishing a location referencing capable service. You don't have to read all of these now, but you may print this later for a quick reference. The common deployment model is to use an ArcGIS server federated with Portal for ArcGIS. The minimum requirement is to have Enterprise ArcGIS location referencing license and location referencing extension enabled in Pro. Now let's go to Pro to start the demo. To prepare the data for publishing a linear referencing enabled feature service, let's browse to the Enterprise Geodatabase in Pro and go to the Geodatabase connection properties. Make sure that branch is selected as the versioning type. Now let's create an LRS dataset inside the Enterprise Geodatabase. So go to the Analysis tab and find the Create LRS Geoprocessing tool. And let's create the LRS. So first thing is to provide the location. The location will be the connection files of the Enterprise database. After this, we are going to provide the LRS name. The rest of the parameters are populated automatically. Next, we are going to provide the spatial reference. In this case, we are going to import it from an existing layer. So browse to a database where the layer resides and point to it. So it's going to be WGS 84 Web Mercator. So on the basis of spatial reference, the XY and Z tolerance and XY and Z resolutions are populated. Let's run the tool. The tool is run, and now we have got the calibration point, red line, center line, and center line sequence layers created for the LRS. And remember, these are blank layers. There is no data in this yet. The next step is to create a network. For that, let's search for the create LRS network geoprocessing tool. So we are going to create a network. So for the location, we are going to browse to the enterprise geodatabase. The LRS name is populated, and let's provide the LRS network's name. The rest of the fields are populated, but if you want, you can change them, and the measure units are going to be miles for this particular network. Let's run the tool, and as a result, a network LRS routes is going to be created. Again, this does not contain any data yet. Now, we will modify the LRS to enable conflict prevention on this data. Eric will talk more about the conflict prevention in his demo. To do so, let's use the modify LRS geoprocessing tool. So we'll provide the input workspace. And this time, we have this option called conflict prevention. We are going to enable it. And let's run this tool. Now, conflict prevention is enabled. To publish the data, let's rename the layer names in the TOC so that they are more readable in the feature service. So let's change the layer names one by one. Centerline sequence, and finally the network LRS routes. The location referencing extension supports time, so let's enable time for the layers. Use the enable time button in the location referencing ribbon. As you can see, the time has been enabled for these layers. Now let's look at the LRS hierarchy after this. The location referencing base layers, including the network, are shown over here. So we are preparing the data for publishing a linear referencing enabled feature service. So let's confirm that we are logged in through a portal. The dataset is now ready to be published. So to publish, go to Share and then Publish Web Layer. Let's fill the item details first. So we'll provide the name, summary, and tags. The reference register data layer type should be feature, and we will share with the ArcGIS Enterprise. Now go to the configuration and select linear referencing. This will enable the linear referencing capability. Next, select the version management. This will enable the branch version editing capability. Next, go to Configure Pooling tab and choose Dedicated Instance. After this, let's go to General and Analyze and Publish to publish the dataset with linear referencing capability. So once we analyze, we see there are no major issues. So we can publish the dataset now. So let's publish. The dataset is now successfully published. Since we created this map for publishing, let's insert a new map for editing. So go to Insert, a new map, and let's name it Editing. What we are going to do is we are going to use this map to add data from the feature service, and we are going to edit the data using a feature service. So name it Editing, and then let's go to Catalog and let's browse to our portal. So the map service that we published, LRS_service, access that and add the calibration point, center line, and the network layers into the editing map. All right, the layers are added. Now let's confirm that these are coming from a feature service. As you can see, the data is coming from a feature service that is shown with the blue symbol. Now let's create our own version for editing so that the default version is not edited. So we'll go to the versioning ribbon and click on new version, provide a new version name. Let's change the data to this new version. And let's confirm that the new version is getting edited. After this, let's fix the symbology a bit before we start the editing process. So we are going to change the symbology of the, let's say, calibration point and the network, and we are going to add a base map at the back. Alright, the symbology looks better now. Let's turn on the base map and we are going to digitize a center line that's going to help us in creating a route. And remember, we are going to use a feature service this time to create a route instead of the direct connection. So a center line is digitized, and we'll go to the location referencing ribbon and click on create route. Let's select the center line and fill up the required parameters. So let's put a start date and the route name. The from measure and to measure are populated on the basis of the geometrical length of the center line, but you can of course change them. So let's make it a little more readable. 0.107 miles is the to measure. The from measure is 0. Let's run the tool and the route is created. Let's turn off the base map to confirm how the route looks like. And so we have the route and the calibration points created. Let's label the calibration points and we can see that the route is created using a feature service. So in this demo, we learned how to prepare data to be published as a feature service and then create or edit the LR data using the REST services. Now, let's have a look at how the location referencing REST API can be used in your customized applications. Over to you, Eric.
Thank you, Raul. Hello, everyone. My name is Eric Blasco, and I'm a software developer on Esri's location referencing team. Next, we will see a demo utilizing linear referencing's REST API to perform an edit on the LRS. In this demo, we will use a service called Postman, where we'll have a collection of requests that we'll use for an edit session. In this demo, we will use environment variables in Postman to store responses generated from the REST request. These variables will be used as parameters later in other requests. Let's take a quick look at the environment variables we'll use for this demo. We have 5 variables which we'll use throughout our edit session. Version name and version GUID are already initialized with the version we'll be using. In this case, editor A will be performing edits on version A. We also have 3 other variables, token, GUID, and status URL, which will be set with the responses we get from our request. On the left, we can see a single collection with all of the requests we'll be using for this edit session. In Postman, we can build multiple collections to automate specific workflows. Once a collection is ready for automation, we can simply run the collection and every request inside the collection will run in series. For this demo, however, we will go over each request one by one. Our first request is to generate a GUID. This will be used as a session ID for our edit session. Since we have multiple requests in the same edit session, we will have to use the same GUID value for each request. Here, we are using an online GUID generator to obtain our GUID value. The environment variable GUID will be set with the response that we get. Our next request is to generate a token for editor A, which will later be used for authentication. This request needs the username and password as the parameters. The environment variable token will also be set with the response we get from this request. The next 2 requests are to start reading and start editing. Both requests are a part of the version management service. For both requests, we will need to provide the session ID and the token values that we obtained earlier in the previous 2 requests. Next, we will use linear referencing's conflict prevention request to acquire a lock. In the acquire locks parameter, we will include the route ID and service layer ID for the LRS network. We will use the route ID for the route that we are adding a calibration point to. We will also need to include our token value and the name of the version we are editing in the parameters. Editor A now has acquired an exclusive lock on a route named North Center Place. Now, let's head over to ArcGIS Pro, where Editor B will attempt an edit on the same route using a different version. Over in ArcGIS Pro, I am signed in as Editor B, who is currently working on a different version. We will try to perform an edit operation on North Center Place, which Editor A had just acquired a lock for. We can use the Identify Routes tool, which is located on the Location Referencing ribbon, to check to see if there are any locks currently on the route we'd like to make our edit on. We can see that North Center Place has been locked by Editor A in version A. Let's see what happens if we try to perform an Add Calibration Point edit to this locked route. We can see an error message as soon as we select the route. The error message states that the route is currently locked by Editor A. Editor B will not be able to continue with their edit. We can also view locks on the LRS by opening the LRS locks table. To do this, select LRS locks on the Location Referencing ribbon. Next, select the feature class that you'd like to view the locks for. We can further refine our search by selecting other options such as user, version, event, or route. When ready, select Apply to view the results. This will give us information on each lock, such as the route name, route ID, user who obtained the lock, the date the lock was created, the version the lock was created on, and the releasable status of the lock. We can see the lock for North Center Place, which was created by Editor A. Now let's head back to Postman, where Editor A will complete their edit session. Next, we will use the linear referencing apply edits to add a calibration point to the route named North Center Place. The edits parameter is required for all LRS edit operations. While we'll only perform a single edit, it is possible to include multiple edits in a single request. In the edits parameter, we include the layer ID for the network we are editing, along with the add calibration point object. The add calibration point object has the parameters route ID, from and to date, which are in epoch time, measure, which is the measure of the new calibration point, and geometry, which is where the calibration point will be added on the route. Other parameters include session ID, token, GDB version, return edit moment, and the return service edit option, which will include all features that were added, updated, or deleted in the edit operation. In the response, we can see that the edit was successful, along with all the features that were added, updated, or deleted. Since conflict prevention is enabled, we will need to run apply event behaviors to update event locations before we can post our edits to the default version. When submitting our request to the apply event behavior geoprocessing tool, we will get a status URL in our response. We will need to use this URL to see if the tool completed on the server side. We will store the status URL in the environment variables to use in our next request. Next, we will use the status URL to see if our tool has completed. We can see that the tool has completed successfully. We also see all server-side messages that were included in the status. Next, to release locks, we can post the edits to the default version using the version management service. We can use the reconcile request with the with post parameters set to true. We will also need to provide our session ID and token value in the parameters. We can see that we have successfully reconciled and posted to the default version. The next two requests are to stop editing and stop reading. For both requests, we will need to include the session ID and token values as the parameters. This concludes our demo on using Linear Referencing's REST API to perform edits on the LRS. As we saw in our previous demo, conflict prevention facilitates coordinated editing when edits take place in a multi-user geodatabase. This is done by enforcing a set of conditions and behaviors to prevent users from making edits without acquiring a lock first. Conflict prevention is only available when using a feature service that includes linear referencing capabilities. It also requires that the geodatabase is set to branch for the versioning type. As we saw in our demo, there are three main stages when using conflict prevention. The first is acquiring a lock before an edit is made. Next, viewing locks to see if a lock was acquired. Lastly, releasing the lock by posting to the default version. We can also edit LRS data by deploying web applications through Web App Builder. You can build and design web applications with various widgets that can meet your business's needs. With custom widgets, you can extend existing operations to improve workflow efficiency. Next, we will see a demo to create multiple routes using GPS coordinates that are stored in a CSV file. We will use a web application that was built using Web App Builder, which includes our custom Create Routes widget. Here we have our web application that was built using Web App Builder. Currently, we can see that no routes or centerlines are currently present in the map. At the bottom, we have a couple default widgets along with our custom Create Route widget. We will go ahead and open the Create Route widget, and we will see it open in the left-hand corner. We can see that we can either drag and drop our CSV file into the widget, or we can select Choose File and browse to the file's location. Now, let's take a look at the CSV file we'll be using for this. At the top, we can see the fields that we'll be including, which are from date, route name, line name, geometry, which will be using the GPS coordinates, from measure, and to measure. In ArcMap or ArcGIS Pro, creating each of these routes could include multiple steps that can be very time consuming. Here, we will instead simply drag and drop our file and let our widget do all the work. We can now see that 70 routes were successfully created. And now we could see the map refreshing. Let's go ahead and zoom in to Route 19. Selecting Route 19, we can not only see that the route was created, but the center line that is needed was also created. We can see here all the information that was in the CSV file in order to create Route 19. That concludes this demo for creating multiple routes using GPS coordinates. As we saw in our last demo, we were able to build and deploy a custom widget that automated the route creation process. In ArcMap or ArcGIS Pro, we would have had to run XY to point, point to line, copy to center line, and lastly, create each route individually. Our widget instead was able to run XY to point, point to line, append routes, generate calibration point, and generate routes, all in a single edit operation. Next, we will see a demo using another custom widget for reassigning a route. For this demo, we will only perform a reassignment on a single route, but we'll be able to use the same approach as before using a CSV file. Picking up where we left off in our last demo, we will reassign a portion of Route 19 to a new route called Route 19X. Opening our reassign widget, we can see it is similar to our create routes widget. Again, we can either drag and drop our file here, or select choose file and browse to the file's destination. Before we take a look at our CSV file, let's get the route ID for Route 19. We will need this value to include in our file. Taking a look at our CSV file, we have a single record for our reassignment. Since each record will be processed by the apply edits REST endpoint, we will need to include all parameters that are required for the request. Next, we will need to update the source route ID, as the route ID was recently generated when we created the route. Lastly, we will save the file. Now we can drag and drop our new saved CSV file into our widget. We can see that one route was successfully reassigned. Let's zoom in and take a look at our route. Selecting the route, we can see the information for both Route 19 and Route 19X. That concludes the demo for reassigning a route using a custom widget. As a recap, in our previous demo, we took a portion of our existing route and reassigned it to a new route. While this can easily be done in ArcGIS Pro, it can become time-consuming if there are multiple reassignments. The widget seen in this demo can reduce this repetitive workflow into a single operation. Now, I'll hand it back off to Raul, who will wrap things up.
Thanks, Eric. Moving forward, here are some resources for the REST API, where we have the REST API Developer Guide, some sample LRS-enabled services, and web app builder samples. Finally, a quick recap. ArcGIS Pro publishes, consumes, and then edits LRS feature services from the enterprise. Portal handles the identity, sharing, and roles that would have previously been file-based or administered directly in the database. The version editing is handled via the VMS or version management service. And finally, branch version database is required for editing a linearly referenced feature service. With this, we are going to end this presentation. If you have any other questions or queries, please feel free to contact us in the following email IDs. Thank you.